So yes, this workshop is going to be, we're going to be giving Go a go, and we're going to be building a REST API in Golang. So hopefully it'll be fun for everyone. So a little bit about me. My name is Angela. I am on an infrastructure security team at Shopify. I'm also part of the dev degree program, or Shopify dev degree program, where I am a dev degree intern. So that means I study computer science at Carleton University and work at Shopify at the same time. 4 years, and I am also a side quest enjoyer. Those are my socials over there. If you have any of them and want to add me, more than welcome. I'll pass the mic over to Addison.
Hi, I'm Addison. I'm also a dev degree intern with Angela. I'm a fourth year CS student at Carleton, and I'm on a database infrastructure team at Shopify. I'm also a scuba diver, very interested in that, and I got back from a month in Mexico recently where I completed over 30 dives. Yeah, and I have LinkedIn, so feel free to add me there. So here's a little breakdown of what we're going to do tonight. We're going to give a little intro to Go, and then we're going to talk about REST APIs. And then the majority of this workshop is going to be very hands-on, where you're actually going to give Go a go. And then we'll kind of wrap up with some closing words and some ways to go further in your Go journey. So let's get into it. So yeah, also before we get started, just make sure everything is completed on the Hack Pack. This will enable you to kind of go through the workshop with us. It won't take too long though, so if you haven't already done it, feel free to do it now. If you have any questions, also just a little bit of housekeeping. There's two of us here, so while one of us speaks, the other one will be walking around. If you've got any questions, just raise your hand. One of us will come over and assist you or answer the questions that you have. If it's like a more general question, we'll also be answering questions at the end, or we might just pause the workshop to answer anything that seems super relevant to everyone else. So yeah, let's get into it.
All right, I'm hoping you all are enjoying these headlines here. So first of all, Go, what gives? By the way, I did not, if any of you have comments about that Gopher logo, I was not the one who designed it. Just a disclaimer there. So in this section, we're going to understand what the language is, how it is used, and why it is a useful language to learn, because it is a very useful language to learn. So it was invented at Google and first appeared November 10th, 2009. And as of today, in 2023, it is the 10th most popular language with around 2.7 million professional developers that use it as their primary language, which means that many, many more probably use it in general in their day-to-day in the industry. And it outperforms quite a few languages, notably some popular ones like Python in terms of microservices, APIs, and other fast loading features. When it comes to NLP or natural language processing, though, that's another story. And in my opinion, it's like C++ but better. It compiles code faster than C++ with help from its concurrency options, Go routines, and also multi-core CPUs. And so, according to the official definition on their website, Go is an open source programming language that makes it simple to build secure, scalable systems. And so today, you might be wondering, well, how's it used? Why have I never heard of it before? It is used for a variety of applications like cloud and server-side applications, DevOps, command line tools, and so much more. And so, which brings me to the next part. Why have I not heard about this language? Or if you have heard about this language, you came to the right spot. A lot of industry-wide or large companies industry-wide use Golang, and on the screen are just a few big companies that either use or have shifted to Go. And according to Hired, Go is the #1 most in-demand programming language across the planet as of this year, and I'm sure the popularity is only growing. And the disparity between why maybe a lot of hackers might not know about this language and is just because it's not necessarily taught in schools or within post-secondary education, and only once people enter the workforce or enter the tech industry do they realize that, oh, this language is actually really commonly used across the industry. And so if you know, you know, and if you're here, you're ready to give Go a go.
Which brings us into our next session, Rest Assured with REST APIs. So we're just going to give a brief overview of what REST APIs are. Maybe you're familiar with what they are, maybe you aren't, but we're just going to catch everyone up before we get into our workshop today. So what is REST? So REST is essentially an architectural style, which just means a design pattern for APIs. So it's like a general guideline for how APIs should be built. And so there's kind of two main players or main words you should understand, which is client, and this is just referring to the person or the software who uses the API. And then there's a resource, which is just any object the API can provide information about. So think about Instagram, for example. Instagram can provide user information, so how many followers a person has, what their username is, but the user would be the object in this case, and then they'd have these attributes to them. And so how it works is that you, as a client, they send a request. So for Instagram, if I was a client, I would say, I would like information about this user, like Angela Chen or something. I would like information about Angela Chen. And then the RESTful server would send back a response that would contain the resource that has all of the user information about Angela. And so another important piece of information to understand is that RESTful applications are stateless. Each request is isolated from other requests. And what this means is that servers do not store any session information. So when you make a request, you have to provide all of the necessary information at each request. So any authentication, validation, anything like that, you have to do that each time. The server won't remember a previous request you made, and it won't remember anything about other requests made by other clients.
And by the way, that is a very popular technical interview question. Explain REST. So now you know. And so now brings us to the question, what are RESTful APIs? And APIs, or API is short for Application Programming Interface, which is essentially a set of rules that define how different applications or devices can connect and communicate with each other. And so all API requests for the same resource should look the same, no matter where the request comes from. And additionally, should ensure that the same piece of data, for example, the email address for Angela Chen, belongs to only one uniform resource identifier. So a very common example of this, of a uniform resource identifier, or URI, is an ID. And REST APIs communicate via HTTP requests to perform standard database functions like creating, reading, updating, and deleting records, which is also known as CRUD, and we will get into that in a few minutes, within a single resource. And so, what are CRUD operations? And so this is also another acronym for create, read, update, and destroy. And here we have a just quick overview of what each action does. And so create allows users to create a new entry in the database. Read has a bit of flexibility here. You can search and retrieve specific records in the database table and read their values, or you can also just read every single value in the database. Or you can also find desired records using keywords or by filtering data based on customized criteria. So for example, I want to find so-and-so using their email. I want to find so-and-so using an ID. And for the U, it stands for update. So you can modify existing records in the database. And sometimes, depending on how your table is or your data is formatted, users may need to modify information in multiple fields to fully change a record due to validations or associations. So for example, if I want to modify a date of something, maybe that resource also has a field called last updated date. And so both of these would need to change in order for me to successfully change the entire resource as a whole. And finally, the D stands for destroy, and it allows users to remove entries from a database. And so now we're going to put it all together. And so first, we got to make some requests. And how do we make requests? We use HTTP verbs and paths. And so in terms of HTTP verbs, there are 4 basic verbs that we use in requests in order to interact with resources. And so, there's some debate on which 4 are the 4, but in our humble opinions, it is get, post, patch, and delete. And you'll notice that some of these verbs are kind of similar to the CRUD actions that we mentioned in the slide before. So can you think, like, can you associate each HTTP verb to its corresponding CRUD action? And in terms of requests, they must contain a path to a resource that the operation should be performed on. And so within RESTful APIs, paths should be designed to help the client know what's going on. And so if we take a look at the example on the screen over here, we see fashionboutique.com/customers/223/orders/12. And so even if you might not have any experience with HTTP verbs or paths, this URL is still clear in the sense that from it we can deduce its hierarchy. So it's going into the customers of this store called Fashion Boutique, and it's finding the 223rd customer, or the customer in their system database with the ID 223. We're going to their orders, and within their orders, we're navigating to the 12th order that they placed, or in this case, the order with the ID 12 in the database. And so when you send a request, you also get a response back from the server. And so responses from the server also contain status codes to alert the client about information regarding the success of the operation. And so on the screen here, we have a few common ones to know. Note that the ones starting with 2 are usually ones that are successful, but even then, they still provide some more information. So for example, 200 is probably the best one that you can get, is just okay. But then 201 provides a little bit more information depending on what HTTP verb you're using. And 204 is also all right, but it's a little bit more specific in the sense that no extra content was made from your request. And then as we can see, the responses starting with a 4 usually don't mean good news. And 500, yeah, that's just not ideal. And then on this image on the side over here, we can have a visual understanding of how the client and the server interact with each other when sending requests and responses.
Okay, cool. So now we're going to get into the workshop component of this workshop. We're going to give Go a go. So it's your turn. Time to build and test a RESTful API with Go with CRUD methods. So let's get into it. So once again, please, if you haven't already, clone our repository. If you don't know how to do that, just go into your command terminal and type git clone, and then just copy paste this link right here. And then also make sure you've downloaded the latest version of Go and Postman, and the links to those are in our hack pack. Another useful resource here is our README from our workshop. It has all of the code we'll be implementing here, as well as some useful information about other aspects of this workshop, including the slide deck. So if you'd also like to additionally look at the slide deck as we go along, you can open it up from the README. Cool, so open this workshop repository in any code editor you prefer. If you did clone a repository like before today, run git pull just to get the latest version of it. We made a couple of changes recently. And then run go get I. And if this is erroring for you, yeah, go get, sorry, dot. If this is erroring for you, then try this little useful thing in the box here, which is run go version, and then navigate to your go.mod file and change the version that's on line 3, and then try running go get I or go get dot again, or period. And if this isn't working for you, then please raise your hand. Angela will come around and assist. But if everything runs successfully when you run a go get period, then yay, you are all set up and ready to go. What this command is doing is it's downloading the source code of the project and its dependencies. So there's some libraries we use here, or some packages, and it's just downloading everything it needs so that you can use those. So for this workshop, we're using Gin, which is a web framework written in Go for routing and JSON validation. And then we're also using GORM, which is an ORM object relation model library for Golang, so that we can make queries to our SQLite database. The SQLite database is hackathons.db, which we'll talk about in the next slide. So yeah, let's take a look at the starter code. So in your editor of choice, open main.go. And as a reminder, if you're having any sort of errors, please just raise your hand. Angela is here and she's ready to assist.
Ready to go.
Yes. But if everything is working for you so far, you ran a go get period successfully, then please open main.go and let's take a look at what's in there. This is the file we're going to be working in. So this file has some code that will just simplify things for you, including a helper method that's creating a connection to the SQLite database, which is hackathons.db that we can query to. We already went ahead and filled hackathons.db with the data we'll be querying. So that's why that exists there. And then this method essentially creates the connection that we can make queries to receive information, update information, add, delete. And then we also have a struct, which you can see in the right corner, and it's called hackathon. And this is what the struct looks like of our the schema of our database looks like. You can see we have an ID, we have the name of the hackathon, we have the date, we have the URL, we have the location, and all of these things except for the ID are strings, which makes things quite simple. And then we also have a main function, and in that main function, you'll see that we have some routes that are commented out, but we're going to uncomment those as we go along. And then there's also a validator, which we're going to use just to make sure that the data we're receiving from our clients is a valid form of data. So that will come into play later. So cool, okay. So now let's get into it. Let's get cruddy. We're going to create our first CRUD action, read. So you'll notice that there's a empty get hackathons method. In that method, please write the following code. So what's happening here is that we're creating a array of hackathon objects. And what we're doing is we are using our connection to our SQLite database to find all hackathons. So we're passing the variable hackathons in by reference. And then this find method, which is a built-in method, is going to set the value of hackathons to the array of hackathon data. And then what this indented JSON method is doing is it is converting our hackathons variable to a JSON format, and then it's returning the status OK, which if you remember is 200, and it is formatting the data into the response. Also in the main method, please uncomment the line router.get hackathons and get hackathons. What this is doing is it's saying when the client makes a GET request at this URL, please run get hackathons, and that will run the method that we just wrote. If you don't like to type code out in our README, we have the code you can copy paste in, whatever you prefer here. It's available to you. Cool. And if you haven't, feel free to open our slides or copy paste the code in. It's all available to you from our README. But I'll stay here for 20 seconds, and then we'll run it and actually get to see how it all works. Nice. Okay. So now we are going to actually test this API that we've written. So what we want to do is open Postman. So open your Postman and then navigate to Workspaces and then My Workspace. And if there's not already a workspace there, then just create a new one. And then in Collections, click the plus button to create a new collection. And then right-click on New Collection and click Add Request. And then you can give your request a name if you'd like, just to make things clear, because we're going to be creating several requests as we go along. For example, I have this one titled Get All Hackathons. And then in your request URL section, type the route that we've just created, which, so you can see we're running at localhost 8080, and then we have the route hackathons. So I'll give everyone a second to do that. If you'd also prefer, you might have noticed something called Postman requests, like a folder in your README, in your starter code. What you could do is in the README, there's instructions on how to import that all those requests into your Postman. So it'll give you all of the requests if you'd prefer to do that. All the requests we'll be using for this workshop that'll be named, and you can just run them. Or you can write them yourself, whatever you feel comfortable with. But we have those available to you. Yeah, can you grab the character from my computer? Cool. Okay, so now we're going to run our program, our Go program. So go back to your terminal and then type go run period. And this just runs your Go method that you've, or your Go file that you've just written. If you see any warnings that pop up, you can just ignore those. They don't mean anything unless it actually errors and your program is not running. Then any warnings you receive are not of concern to you. But if you have an error and for some reason can't actually run, and you don't see this gin debug get hackathons and then it says main.get hackathons, like if you don't see that, then please raise your hand. But if you see this output, gin debug get hackathons, main.get hackathons, then you've done everything correctly. And now you can return to Postman after you see this in your output and click the run button, which if you don't remember is like send, sorry, it's not run, it's send. So click the send button, which is right next to the URL section. And then in the body of your response, all of the hackathons will be listed in JSON. You should see 271 of them. So yeah, just take a moment to like explore all of the data, make sure everything's running. As I mentioned, Angela's walking around, so if anyone has any errors or any questions, she'll be there to answer those. Before moving on to our next step, you're going to want to stop your server in your terminal by typing Control-C. It's important that you do this before rerunning your server, because what will happen is that you have something running at a localhost 8080, and then if you try to run over that, it's going to tell you there's already something running there. So just make sure you Control-C to stop your program fully and kill the process so that you can rerun it. Because how Go works is you're going to need to stop your process every time you make a change that you want to test. So after you've checked all of this out, you feel good about it, then please stop your program, and then we'll move on to our next step in a second. And Angela, if you'd like to come back up and take the next part, I can switch off with you. Yeah. Okay, I'm gonna go over there.
All right, so hopefully everyone's getting something that matches the screen here with their Postman testing. And so next, just before we move on to the next step, don't forget to stop the server in your terminal by pressing Control-C. And all right, it's time to get cruddy again. And this time we're doing a read function as well. So in get hackathon by ID, please write the following code, or as always, feel free to go to our README and you'll be able to copy the code in one go. And so this time, in this get function, we're actually getting a hackathon by ID. And so in this code, what we're doing is first, we're setting a hackathon variable called hackathon of type hackathon. And then we're going to query the database for all of the hackathon entries and set the value of our variable hackathon to the actual hackathon with the same ID as the parameter argument if it exists. And so here we see in the code that the variable ERR is, or error, is set to the result of searching through the database where the ID is equal to the same ID as the parameter that the user put in, or the whichever one is the first one that pops up, and it takes the reference of that hackathon, and using that object, there is an attribute called error, and it sees whether or not it resulted in an error. And so if everything goes well, if everything goes properly or as expected, the error value should be nil because nothing went wrong. We were able to find an appropriate hackathon with the same ID that we were looking for. But in the event that it is not nil, the error or something does go wrong, the error variable would not be empty. Something would be in that variable. And so in the next block with the if statement, if it is not nil, then we would return a bad response, or in this case, http.status bad request, and with the error message, hackathon not found. And so if that block is never entered, though, that means that error was nil, and that means everything was fine. And so we return an OK HTTP status with the data wrapped in JSON format with all of the information about the hackathon that we found. And so once you've put that code in the get hackathon by ID function, also head to main and then uncomment the line router.get hackathons/:ID, and then get hackathon by ID. And as you can see here, the path is a little bit different than before with our previous read function. In this case, we have a parameter, or as you can see in the path, we have a /:ID, which means that is a parameter that we're looking for from the client. And also the path is different than before. And so as a result, we will be getting a different response. And so when a GET request is made at that path, the get hackathon by ID function will be called. And I will stay here for about a minute or so, just so everyone has time to process that and put that into their code. And then we'll head on to the next step of testing that in Postman.
Quick question.
Yeah.
What is happening in JIT.context? Like, what are we passing?
Sorry, could you repeat that?
What exactly are we passing to the function? Like, what is JIT.context?
Oh, yes.
Yeah.
Yeah, good question. So in that case, what we are passing in is the the body of the actual request that we're sending through Postman. So first, within Postman, we have a path, and then it will find the literal context of the path itself. So in this case, it's mostly just a routing between using the Gin module, which will just know within the main function, you see that we have the path and then the method. So it just knows that to associate that method with this path, and then everything will be routed correctly, and then it can send the appropriate result back to the request, whoever made the request, yes. Because within the code, we also see c.json and in two parts. The first one is if it errors, and the second part is if it all goes well. So using that object, we can send the response to back to the appropriate place. Yeah. Yeah. That's a good question, though. Thank you for asking. Yeah. All right. And so for those who are ready to test in Postman, in order to start that back up, we got to start up our server as well, again, with the command go run period. And then you can create a new request within Postman by right-clicking and then selecting add request. Or if you imported the Postman JSON template within our README, you can just click the get hackathon by ID workspace. And so in this example, we see that we put hackathon/1. So we're looking for the hackathon within our database that has the ID of 1. And you should receive the data that is corresponding to the hackathon called Hack the Runway. But if you're feeling experimental, replace 1 with another ID and see what happens. What about an ID that you know doesn't exist? Inside our database right now, the hackathons go up to ID 271, I believe. So try 272 if you want. See what type of result you get, if it's even possible. You could try 0, because I can't remember what number the IDs start at in our database. But I'll give another 30 seconds for that, and then I'll hand the mic off back to Addison. And as always, please raise your hand if you have any questions or are stuck anywhere.
Cool. So hopefully you've had a chance to run this and play around with it and see if you can request specific hackathons by their ID. Just as a reminder, if you're feeling a little bit behind, you can always import the Postman requests into Postman by following the instructions from the README. To do that, there's a section of that. You have all of the requests in your starter code if you'd like to do that. There's also the code in the README if you'd like to catch up that way as well. And now we're on to our next CRUD action, create. So with create, you're actually like changing your database, which is very exciting. So one thing we need to do is, so you're the client and you want to create something. So you're giving the server the information that it needs so that it can add that resource in. So we need to create a struct that we can validate against. So how we're going to do this is we have a hackathon input struct here. And it just has the name, the date, the URL, and location, because we don't need the ID from the client, right? Like we will figure out the ID ourselves. So we just want these 4 things from them. And you can see here, there's this validate. So this is where our validator comes into play. So what the validate does is here we just have required, but you could have several things here. But essentially, we just don't want any of those fields to be empty or missing. We want a hackathon to have all of these things. Otherwise, we don't have enough information for a user. So in addition to adding this struct in underneath your hackathon struct, in the create hackathon method, you're going to want to write this code. So this is just half of it. We have continued on to the next slide, some other stuff. So what this code here is doing is it's creating an input variable of the type hackathon input. So something that's going to have a name, a date, a URL, and a location. And then it is using our context that we passed in, c.shouldBindJSON, and then we're passing input in by reference. So it's looking at the body of the request, and it is binding that JSON to our input. And so if we're unable to do that for whatever reason, if it errors, then we want to send a bad status request and say that there was an error and give the error back to the client so that they can correct their request. And then what the next error validation is doing is it's actually validating that our struct has all of the necessary information, that it has a name, that it has a date, that it has a URL, that it has a location. If it can't do that, then we're also going to give an error back to the client. And so that's what these first two errors are doing. And then the rest of this method, we are creating our own hackathon object here. So we are setting each value ourselves. We are finding the number of hackathons in our database already by looking at db.find all of our hackathons and then rows affected. So just looking at the number of rows. It's a really convoluted way to find the size of our database, but it is the only way to do it, unfortunately. So it's kind of silly, but that's just the way we get the number of rows or the number of entries in our database. And then we're adding 1 to that. And then we also have our name, our date, our URL, and our location from the input provided by the user. And then we are making a query to our database to create this hackathon object we've created by passing that in by reference. And then we are sending a status back to the client to tell them that everything went well, that their request was received, and that we actually created the hackathon by just returning the hackathon that we created. In main, make sure you uncomment the line router.post hackathons create hackathon. So it's kind of interesting. You can have the same route, which is hackathons. We have a get request to it, and we also have a post request to it. And it's the same route. And we'll show you kind of what that looks like in your actual request once we get to the postman part. This is a lot of code, so it is on a README if you would prefer to copy paste it in. You'll have some time to freestyle with the code a bit towards the end. But for now, we want to get you guys set up with all of the, CRUD CRUD actions. Yes. Oh yeah.
Why do you say that's the only way to ID?
Mhm.
That's the only way you can increment the find the
Oh.
ID. Can't you just keep somebody called a variable or something?
Oh, sure. So, okay, yeah, we could definitely do that if we wanted to create a variable in the main method and then run this once from main and then just use that variable and increment that throughout our session. Then we could do that. But once we stop our program, then we'd have to rerun it. And this is just the way that Gorm, the actual package we're using to make queries to our database, can check the number of rows. But we definitely could, I see what you're saying, we could definitely make less queries by running this once in main and then having that variable persist throughout the time we're running our server. That's something you could definitely do and try out if you'd like. Yeah, that's a good idea. So now go back to Postman. Make sure you've stopped your previous run by Control-C and then start it up again. And you're going to make a new request. And so you'll notice in the yellow square that it's no longer a GET request, it is a POST request. So it's to the same URL that our GET request was to, but now we're saying that we want to post to that endpoint and not GET. Then navigate to the body and then click raw, and then make sure that you're selecting JSON. So this is the body of your request. So this is what we were referring to previously in our method when we were like getting information, getting the context or getting the information from the body of our request to bind that request, the body of that to our input variable. So that's what that actually looks like. So you can see body and then raw, which is the purple square, I guess, and then the like light blue square. Make sure you have JSON selected. And then make sure you're creating an object here, a JSON object that has a name, a date, a URL, and a location. Here we have the example of Hack the North, but you can use whatever you'd like. And then when you're ready, you can send that. And if you've done everything correctly, it'll return your hackathon. It'll have the ID of 272, and it'll have the name, the date, the URL, and the location that you sent. For fun, try removing something. Try removing the URL completely and just sending a name, a date, a location, or just making any of these an empty string. And make sure that that errors. It should send an error back and be like, hey, you're actually missing a field here, because that's part of the validation that we wrote. So yeah, I'll give everyone a second to try that out. Just play around with it, add as many as you'd like in there. And then Angela will take it away with our next CRUD action.
All right, so now our next CRUD action is update. And so by now, you guys have probably gotten the hang of this. We've kind of gotten used to the way we add to our methods. And so this time around in Update Hackathon, please write this code. We'll also let you copy paste this one if you'd like. For now, we're just showing a section of the code. This part is slightly longer, and so we've separated it into a couple slides just so we can make sure we fully explain and that you all can fully understand what we're getting at here. And so with this, first we are doing something similar to our get hackathons by ID function, where first we are going to look for the actual hackathon object that the client is looking for by ID. And so again, we're going to parse through the entire database, look for the hackathon object or resource that has the same ID as the ID parameter the client passed in with their path, and set it to our hackathon variable, which will happen on the next slide. But right now, we're just error checking. And so if it doesn't exist, right away, it will throw a bad request response back with the error message, hackathon not found. But if all of that is good, then we will move forward with the next part of this function. And so in this case, when a patch request is made at hackathons/:ID, notice how this is the same path as the get hackathons by ID method, but in this case, the HTTP verb is patch and not get, and thus you will a different method will be called, and you will also get a different response. And now we are continuing within the same method. In this case, we are first, we're going to try and bind the input to our new JSON response. And so again, we have some error checking. If this is unsuccessful, then we throw another bad request response with the error message that we received. And so what we're doing next is we're going to validate the structural integrity of the body that the client put in. We're going to see if the structure of the body matches the structure of the hackathon input struct, just so that when we do go to input this hackathon into our database of hackathons, the exact formatting, the data types, the names, and all of that is good to go within our database. And then if all of that is good, then at the very end, we finally update our database model with the new resource. Well, it is a pre-existing resource, by the way. It's just we are finally going to go through with updating that resource, finding it by ID, and then updating it with whatever the client passed in with the body of their request. And so after that, only after that will it return an OK response with the data or the updated data of that hackathon. And so what this entire method does in one sentence is just it finds the hackathon in the table based on ID and then updates that exact same entry within the database. And so the last step, after you've copied this piece of code and entered it into the update hackathon method, you're going to uncomment the line router.post hackathons, or I think it's patch actually, /ID and update hackathon within the main function. And then we'll get to testing that out in Postman yet again. I'll give people a minute or so just to wrap that up. All right, and so we're going to test in Postman again. Before restarting your server, please make sure you've stopped your server first in the terminal, just so that our changes with the code can be reflected appropriately. And then we're going to start up our server again with go run dot. And then so we are going to run in Postman. If you take a look at the yellow square or yellow box on the screen, the HTTP verb we are dealing with in this request is patch. And then within the within the URL, we're going to put whichever ID of the hackathon that you'd like to modify. And then in the body, and again, we want to select JSON formatting for the body section, you're going to input whatever data you'd like to update that hackathon with. And we're going to take a look at what that does. And so after running the patch command, go back, or patch request, go back to your get request for all hackathons. Do you see a difference or different information for that same hackathon that you just switched within your database? You can also try querying for it in your get request if you don't want to scroll all the way. For example, if you chose to change the hackathon 272, probably don't want to scroll all that way. But I'll also give folks a few seconds for that, or a few moments for that.
Amazing. So hopefully you guys were able to successfully update your entry. Very, very exciting. We are done with the C, R, U, and now we are on to the D, delete, the last part of CRUD, and then you'll have like the full acronym, which is awesome. I know at some point it does start to feel a little bit repetitive, like you're kind of, a lot of the code starts to look the same. Which is a good thing because hopefully that's kind of just like, oh, I'm understanding this better each time we're doing it in a method. But yeah, so now we're on to delete. So this is our last one. And you'll see here that once again, just like in the update, we are searching for the hackathon by ID. And then we are getting the first hackathon that has that ID. And if there is no error, that is amazing. If there is an error, then we just say, hey, we couldn't find that hackathon that you're requesting, and we return. But otherwise, we delete. It's very simple. we just make a delete query to our database. It deletes the hackathon that we've passed in. And then we just return the OK status. And we, in the body of our response, we just say true. It's very simple. And then make sure you uncomment in your router or in your main method, router.delete, and then at this route here. And then we're going to use the delete hackathon method for that. Cool. Okay. So now, once again, make sure you've stopped your server and then start it back up, and then try writing this one on your own. So some things to consider here. What HTTP verb do you need to use here? Which, as a reminder, the HTTP verb is like the one that is on the left side of your URL. So, you have all these options when you click that as a dropdown. Which one do you think we should use here? What URL do you need to use for the request? Hint, it's in the part of the code that you uncommented in main. And also, how can you check that your request was successful aside from the response? So the response will tell you, obviously, you'll hope to see data true, but are there other requests you can make so that you can just further confirm that everything you've done here is great? And I will give you guys a little bit to experiment with this, but we'll have the answer on the next slide. So did anyone get it? Does anyone want to answer which HTTP verb that we should use here?
Does someone want to give it a go?
Yeah.
Noah?
Delete.
Thank
Hey.
you. Yes, delete. Which URL do you need to request?
No, she was just.
We're gonna. I understand it's like 2:30, so I get it. But here is the URL we should have created. Well, you could query anyone, honestly, but we chose to delete the entry we created, so 272, and make sure you have that delete, and that's all you need. You don't need anything in the body of your request. You just need these two elements here. You should send that. It should say data true, and then some ways you could test this are trying to get that. Hackathon, so hackathon with element 272, and it should return with a hackathon not found. Or you can just run for all of your hackathons, and it should be missing from the list. And those are some ways you can confirm it. So yeah, congratulations. You've successfully created a REST API in Go with CRUD methods.
Oh, wait.
Wait.
Sorry.
We still
sorry.
have a bit more, though.
Sorry. We know you gotta go. We gotta go too. But just to wrap up the workshop, we're gonna discuss some resources for continuing with your Go journey and how to take this REST API even further if you are looking for a challenge. And so, how to go further? With regards to this thing that you have now from this workshop, which is a REST API, you can try writing your own API requests in Postman. For example, try writing a GET request method, but instead of retrieving by ID, retrieve by hackathon name. And so where the difficulty comes from with this is that some hackathon names contain spaces, apostrophes, and special characters. So how do we delegate those? How do we resolve those? String manipulation, UTF encoding, or regular expressions are all potential solutions depending on how you want to look at it. You can also write a patch request method that only updates the date of a hackathon instead of the entire object. Or, if people are really feeling audacious, you could build a front end for the REST API so that it becomes a full-fledged web app that you could potentially submit to the hackathon. Hint, hint, nudge, nudge, wink, wink. And for resources, if you're interested in taking this further, We have the official Golang website with pretty good documentation, in my opinion, and also their own Learn section over here. We also have an interactive module and introduction to Go that both Addison and I needed to complete for work back when we first started working with Golang. In our opinions, it's pretty good. The documentation for this language is pretty comprehensive, which you'd be surprised. Some very well-established languages out there still have pretty bad documentation. And so a few more links for some specialties or where Go stands out in comparison to other languages. It's really good for concurrency and also just inherently within the language. It has great support for concurrency and also for cybersecurity, which we have also both experienced within our own lines of work. And so there's some links. Yeah, thanks for giving Go a go. We had a good time. And yeah, if anyone has any questions, please feel free to ask. We'd be happy to give them a go.
There's no one else in the room after us, so if you'd like to come up and ask us questions, we'll be around. Thank you so much for, not sleeping and being here with us tonight, and good luck on hacking. If you guys are participating in the scavenger hunt, which you totally should, then you should scan this QR code and say something cool that you learned from this workshop. Once again, thank you. Yeah, we'll be around.